Okay, this is notes for 7-1, linear and nonlinear systems of equations. We'll call this part 1. This is Tuesday 320. And you're going to find that for a lot of this, it's review of things that you've done before, graphing linear systems of equations to find points of intersection, using the elimination method, the substitution method. The only thing probably that is very new to you is, have you had things like 3 variables, 3 equations, 3 unknowns, 4 equations, 4 unknowns? Things like that. So we'll up our number of equations and number of unknowns sometimes for this. So this is called linear and nonlinear systems of equations. We're going to use the method of substitution to solve these systems. So that's a review for us. We'll use the method of substitution to solve systems of nonlinear equations. And probably in your past you haven't done a lot of work with that, nor will we here. We'll use graphing to solve systems of equations, and we'll use systems of equations to model and solve real-life problems. So kind of it's called linear programming. I don't know if, I can't remember if you've had problems like that before as well. So we start out with the method of substitution. This should be pretty straightforward for us. And this is where often we have 2 equations, 2 unknowns. One of the variables has a coefficient of 1, so we get that one alone, and then we substitute that into the other one to find what we have. And so when we're looking at more than one variable, and so, you know, this says science, business, engineering, 2 or more variables, 2 or more equations, and so a lot of times we're looking at different dynamics, like, you know, the constraints we have for time, the constraints we have for resources, how much of something we can package together as we go through things, and just kind of optimizing in all these areas of business and science and engineering. We're usually optimizing something, and we either want a minimum or a maximum. So if it's costs, we want it to be a minimum for us, or and if it's our profits, we want it to be a maximum sometimes. And we're solving systems of equations. So, excuse me, here's just a set of an example of a subsystem of equations. Wow, that just did not come out very well. And a solution is an ordered pair that satisfies both of the equations, and we're going to solve that system as we go through. And this isn't even going to solve it. It's just going to say, here, if I tell you 2,1 is a solution, and you're going to check that 2,1 is, you put 2,1 into equation 1 and equation 2. So generally, we should know if our answers are correct as we go. So here's the method of substitution. You're already familiar with it. Maybe just write yourself a little note. You solve one of the equations for one of the variables. You substitute that expression that you found into the other equation, solve to find one of the variables, and then back substitute. That word back substitute is used a lot in this chapter, and that's not a phrase that we've often used, but back substitute means just to put that first answer back into one of the versions of our original or of our equations, and then find the other one, and then just check that it works. Ready for me to move on to the next slide? Okay, so that's just our little direction piece. Here's our first problem, and I'll just rewrite it. That kind of helps me time myself as I go. Maybe I'll rewrite it. There's number one. And so we'll also use these kind of braces to offset them. And then this is x plus y equals 4, x minus y equals 2. And so that's our two original equations. In this case, all the coefficients are either 1 or -1. So we have a lot of opportunities. And I'll just go through this in a very direct way. So step one is to solve for one variable in one equation. Doesn't matter, since it's easy for both of them, I'm just going to pick x plus y equals 4, and I'm going to solve for y by subtracting x, so y equals 4 minus x. So that's all there is to step one in this particular one. And then step 2 and 3 are kind of together, and that is to substitute that expression, this expression into the other equation and solve. So the other equation is x minus y equals 2. That was what y is equal to, so we're going to take x minus, then the expression 4 minus x is equal to 2. And so I'll just use a little color coding. So that's our 4 minus x for that one. And then generally for this linear system, it's going to be very straightforward for us. So x minus 4 plus x, be careful when you distribute, equals 2. 2x minus 4 equals 2. 2x equals 6. X equals 3 for that. So there's steps 2 and 3 were to kind of do that substitution and then finding one of the variables. Then when you substitute in to find the other answer, really when you're using substitution, it might be the easiest to use that one, y equals 4 minus x, but truly you can use any of these just to kind of let you know as you go. So now I'm at step 4, and for step 4, the version I'm going to use is y equals 4 minus x, that from step 1, and then y equals 4 minus 3, and y equals 1. So then that gives me a solution, and in this case the solution is an ordered pair, and that is x is 3, y is 1, so 3, 1. And then we just want to check as we go. And I would say checking in your head for a lot of these. So 3 plus 1, and how does that compare to 4? It is 4. And then 3 minus 1, how does that compare to 2? It is 2. And so the check for that one is pretty straightforward. The other kinds of things that we have to do is maybe solve a word problem kind of problem. Do we all agree that's very straightforward and we've all done it before? So this starts out to be a pretty straightforward section here. And let me find the next problem. The term back substitution implies that you work backwards. First you solve for one of the variables, then substitute back into the equation. So here's our next problem, and hopefully we can see all that. It looks like it. So example 2, and this is now a word problem kind of situation. So here's what it says. A total of $12,000 is invested into two funds paying 5% and 3% simple interest. So we're lucky that it's simple interest. Interest equals principal times rate times time. And recall that the formula for simple interest is I equals PRT, where P is the principal, R is the annual interest rate, and T is the time. So your yearly interest is $500. How much is invested at each rate is kind of what you have to figure out for that. And I will just write myself a little note that I'm using I equals PRT. and just simple interest, not per, not um, calculated at different times and things like that. So we're just going to say let X equal the amount invested at, and it doesn't matter which one does it say first, 5% we'll say, at 5%, and Y can be the amount invested at 3%. So just a reminder, I equals PRT. So we have the amount interest invested at 5% is X. The rate is 0.05. And time is just going to be maybe however many years or 1 year or whatever. And the yearly interest. So it's 1 year. And then the other one, Y, is invested at 0.03, and that's also at 1 year, just to kind of know where we're getting things as we go. Now, the things we have to think about in regard to this is that we have our yearly interest is $500, and we know we've put in a total of $1,200. So if we put in X at 5% and Y at 3%, how are X and Y related to 12,000? Yep. So one equation is going to be X plus Y equals $12,000. So that gives us one of our equations, those two amounts that we've invested, just to add up to that as we go. And then the other equation is going to come from the yearly interest is $500. And so we've kind of figured our interest here. And so to get our interest on that 5% pot, so to speak, it'll be 0.05 times X times 1. So 0.05X plus 0.03Y equals, and so that's the interest from the 5%, the interest from the 3%, and we know that our total interest is $500. So we get our two equations and two unknowns. Now, you all have calculators, and that's all wonderful and everything. But sometimes I don't have a calculator, and so sometimes I multiply everything by 100, and then it just makes it easier for me. Is that okay if I do that? Do you mind if I do that? And so I'm going to just multiply that one by 100. That just makes it easier for me. And then my equations are X plus Y equals 12,000 and 5x plus 3y equals 50000, 50,000. You do not have to do that, but that's, a strategy, or for me when I don't have that as we go. So step one is to solve one of the equations for one of the variables. Do you agree that I'm going to use the first equation, right? And it doesn't matter. I'm just going to solve for y. So I'm going to say y is 12,000 minus x. And then for steps 2 and 3, I'm going to say 5x plus 3, and then I'm just going to leave that times that expression is equal to 50,000. And then I'll just plug that in, 12,000 minus x. And then go ahead and I'll have you guys tell me what to do. Distribute that through Lewis and tell me what to write down. $50,000. Yep. Distributing gives us that equation, and then combining like terms. What does that give you, Ashton? And Liz, what am I going to do next? And what do I get? 5x equals 14,000. Oh, you know what? Wait, I miswrote something, didn't I? And you said 2x, I think. Yeah. Uh, Ashton said 2x, and I wrote 5x there because I'm just like in my head right now. I was like, wait, something's wrong. But so my correction there. And then Sarah, what are you going to do next? And what does x equal? 7,000. And then Austin, how am I going to find y? Yes, or I would even maybe put it in that version. Yeah. So how are you going to get y? 12,000 minus 7,000, and it is 5,000. And so keep in mind if we graph these, that would be the ordered pairs 7,000, 5,000. And then if we just do a quick running check for ourselves, and maybe I'll put it so I can see everything there. I'll just do my check right here. 7,000 plus 5,000. And how does that compare to 12,000? It is 12,000. And then, I'll use my big number one, or I wouldn't really have to. 5 times 7,000 plus 3 times 5,000. And how does that compare to 50,000? There we go. And that's 35,000 plus 15,000, and so those are the same. And in a problem like this, we want to maybe give a summative answer that kind of explains what we're having. So what is the $7,000? And what about it? Yes, so we'll say $7,000 is invested at 5%, and $5,000 is invested at 3% for that one. So all pretty, very straightforward things. Now we want to next look at things that are nonlinear, and we're still using that substitution method, but probably this is something we have not used as much. And systems. Oh, I'm sorry. It did have a heading. I forgot. This is nonlinear systems of equations, and it's not going to be terribly difficult for us. But we will have kind of a key strategy for this substitution. If we're using substitution, we know generally we've wanted to get the variable with the coefficient of 1 alone. Well, in nonlinear systems, we want to get the variable alone, or a variable alone in the linear if we have it, or the lowest powered equation. I'll just say it that way. And most of the time that should be linear. So the equations in example 1 were linear, and substitution is used there. But now we're going to use substitution again. One is linear, one is not linear. So this is number 3, and it's 3x squared plus 4x minus y equals 7. 2x minus y equals -1. So my hint to you, or my note is the easiest strategy is to get a variable alone in the linear equation. if possible. So kind of think about that. You know, do you agree we could get y alone here, but if we got y alone, we'd have like that. We'd have 3x squared plus 4x minus 7 equals y. So that's like 3 terms, and then we have to put it in here, and then it's a quadratic that we have to solve. Whereas if we take this one, and also you want to think about which variable to solve for, so it's not always going to be the one that's not going to give you a fraction, but in this one we will do it that way because we're still going to end up with a quadratic as we go through. But now if we solve this for x, not only would we get a fraction, but we can't care about that as much. But then we'd have to square this, and we'd have to distribute that, and then we just have a big mess. And if we do this y, then we'll have a shorter expression as we go. So I'll number these steps like before. So step 1, I'm going to pick the 2x minus y equals -1, and I'm just going to solve for y. So you do want to pause a minute and think about what might be the best course of action for that. And let's see, if I get y alone, it'll be 2x plus 1. Let me just do it this way. -2x minus 1, y equals 2x plus 1. And then for steps 2 and 3, I'm going to take the other equation, and maybe I'm going to move some things. Oops, wrong thing to move. I'm going to move this over a little bit so I have just a little more room here to write some of that. Now I'm going to take that first equation, which is 3x squared plus 4x minus y equals 7. 3x squared plus 4x, excuse me, minus, and then I'll put that stuff in parentheses, equals 7. So now I'm going to distribute or put in this 2x plus 1. And notice how I'm doing that. I'm intentionally, like, waiting to write it in a different color, but I'm also putting a parenthesis around that to just make sure that I'm doing what I need to do as I go through. So work us through this. Austin, get me to a point where I have a quadratic equal to 0. So distribute that first. And let's bring over, yeah, and then do some, I don't know, what do you get then? Okay, so you take a minute and factor that and find what x is equal to. And so whatever method of factoring you want to use, you go ahead and factor that and see what happens. So I'm just going to write up the factors now. 3x squared, I would just guess and check for this one. 3x squared has to be 3x and x. 8 can be 8 and 1, 2 and 4. 1 is positive, 1 is negative. If I put a 4 here and a 2 there, I'll get a 4 and a 6. That'll give me 2. I want the 6 to be positive. I want that to be negative. So x equals 4/3, or x equals -2. So those are my values for x. And then to find my y values, I'll use this. And so this is step 4 to substitute that back in. So if x equals 4/3, y equals 2 times 4/3 plus 1. And so that's 8/3 plus 3/3. I'll just get a common denominator right away. So y is 11 thirds. So that gives us one ordered pair of 4 thirds, 11 thirds. And then for our second ordered pair, x equals -2. So y equals 2 times -2 plus 1. Y equals -4 plus 1. Y is -3. And so our other ordered pair is -2, -3. And I'll leave the check to you. And so just being careful as you check, you need to check it into the original as you go. And I have checked these, but I'll let you do that, and we will be done for the day.